Factoring. We're going to talk about factoring for the next 2 weeks. First part of factoring, you can't do any factoring unless you know the GCF, the greatest common factor. To find the greatest common factor, there are a couple of strategies. One, you can have enough number sense to look at 18 and 12 and automatically know what is the largest number that can go into both of those digits.
6.
Ooh, maybe. Or you're the kind of person that just pounds away in their calculator. Let's try 2. Let's try 7. Let's try 9. And get your solution that way. Or I'm going to show you the step-by-step algebraic way of how you find the GCF. Foolproof. It's a long way, but it guarantees the work. First thing you need to do is to take your numbers and find the prime multiples. Prime numbers being 2, 3, 5, 7, 11, 13. What's the next one?
15.
Nope. That's divisible by 5 and 3.
17.
17, very good. But we usually don't get really larger than 13 in this class. So here's the ones you really need to know. I want to break 18 down into the prime multiples. So first, let's look at our first prime number, 2. Does 2 go into 18?
Yes.
Okay, 2 does. How many times does 2 go into 18?
9.
It goes in 18 9 times. Is 9 prime?
No.
No. So let's start over. Let's find our multiples of 9. Does 2 go into 9?
No.
Does 3 go into 9?
Yes.
How many times does 3 go into 9?
3 times.
3 times. And is 3 prime? It is.
Yes.
So I'll move it over here. Some of you do the factor tree. So like 18, 2, 9, 3, and 3. That's fine. I do it this way because it lines up to when we do the next step. So 18 is 2 times 3 times 3. 12. Let's do the same process, but with 12. Does 2 go into 12?
Yes.
How many times?
6.
Is 6 prime?
No.
Nope. We'll start over. Does 2 go into 6?
Yes.
How many times?
3.
3 times. And 3 is prime. So 12 is 2 times 2 times 3. These are my prime multiples of these numbers. Step number 1. Like so.
Good job.
Step number 2 is to find what they have in common. So what the multiples do they have in common? They have a 2 in common and
3.
And a 3 in common. That's why I do it this way other than the tree. That way you can just circle at the same time. So they have a 2 and a 3. And 2 times 3 is?
6.
Hey, you were right. The GCF is 6.
That's
The
long.
biggest number that's divisible into both of these. It is long, but it works.
Yeah, but the other shorter way, I know there has to
Oh, do it. Okay, I'm just saying. I'm just showing you. Just showing you.
Thank you. Didn't
I can't exactly show you. Here's how we're just going to guess and check on the calculator. That's not me getting my paycheck. Now, 39. What are my prime multiples of 39? Does 2 go into 39? No. Okay. We'll move on to the next prime numbers. Does 3 go into 39?
Yes.
How many times does 3 go into 39?
18.
13.
13 is not
13.
correct, but 13 is.
Yes.
Is 13 prime?
Yeah.
It is. Hey, we lucked out. Only 2 terms. So 39 is 3 times 13. On to the next number, 6. Does 2 go into 6?
Yes.
How many times?
3.
Is 3 prime?
Yes.
So I'll move it over here. And is that all my prime multiples?
No. Oh wait, yeah.
3.
Yeah.
So they're just on a line.
So, what's the next step?
Circle the 3.
Yeah, circle what they have in common. They have a 3 in common, which means what?
13 and 2.
Oh.
Oh, sorry.
My GCF is
3.
3.
Oh. What's the other one? Didn't you multiply?
Oh,
This one
mhm.
didn't multiply.
Why didn't you multiply these?
The other one, good question. I didn't multiply 2 times 2, 4, and 9. I multiplied, I took a pair of 2,
Oh.
a pair of 3, and I multiplied those together.
So since there's only one, it's only one answer.
Yes. So here, I have just a pair of 3s. So it's just a 3.
You got
Yes. Now let's introduce variables, which is easier than the numbers, I promise. So we already saw 39 as 3 times 13.
Yes.
But now I'm also multiplying a b. So 39 is 13 times 3 times v. Negative 30 uv. So I have this negative, I'll write as a negative 1, times 30. Does 2 go into 30?
Yes.
How many times?
15.
15. Does 2 go into 15?
No.
All right, the next one. Does 3 go into 15?
Yes.
And it goes into 15
5 times.
5 times, which is prime. Now, I also have a couple of variables. I have a u
And a V.
and a v.
You be like.
Oh my god.
So here are my prime multiples. What's the next step? What do they have in common? 3
And a V.
and a v.
So 3V.
So my GCF is 3v.
Wow. That's good at this.
That's it.
Period. Oh, so the negative doesn't matter.
Do they have a negative in common?
No.
No. So your GCF is assumed to always be positive unless they're both what?
Negative.
Unless they're both negatives. So yes, we can just discount that negative. Now let's put exponents into our variables and see how that works. So we saw 30 as being 2 times 5. Some words of advice: if you get lost in your prime multiples, just go ahead and put this in the calculator. It should come out to be 30. So 3 times 2 is 6, 6 times 5 is 30. Okay, I have them all. Y cubed is how many y's?
3.
3. So 1, 2, and 3. We'll go down to 20y squared. Does 2 go into 20?
Yes.
How many times does 2 go into 20?
10.
10 times. 10 is not prime.
5.
5 goes into 10 how many times?
5.
2 times. And 2 is prime.
Period.
Y squared has how many y's?
2.
2 y's. And now we're looking for what they have in common.
The 2.
They have a 2 in common
And a 5. So 2 times
and a 5 in common.
And 2 times 5 is 10.
So 2 times 5.
It's 10.
What else do they have in common?
2 Y's.
And 2 y's. Y times y. So 2 times 5 is 10. And y squared. That is my GCF.
Wow.
Please note, we were talking about the greatest common factor. Why isn't y cubed here?
Because the other one doesn't have.
Exactly. You don't have a cube. You can't put a big number into a small number, can you? It won't fit. But you can't go the other way around. So you're going to have difficulty with the numbers. Find the GCF. The exponents and the variables should be easy. You're just going to take this smallest one. You can put a small exponent into a large exponent. So if I change this to a 5 and a y6, what's going to be my GCF? Y what?
5.
Y5. If I change this to 11 and this to a 16, Y 11. Smallest one. If I change this to 37 and this one to 16, this is Y 16. So yes, just grab the smallest exponent. That's a quick way of doing
So
it.
we wouldn't have to solve it. Just get the smallest exponent.
Yes, you would have to do all this. Just grab the smallest exponent. For instance, what is my x GCF going to be?
2.
X2. Very good.
Squared.
X squared. So let's look at 80. Big number. Does 2 go into 80?
Yes.
That makes that 40. Does 2 go into 40?
Yes.
That makes that 20. Does 2 go into 20?
Yes.
That makes that 10. Does 2 go into 10?
Yes.
That makes that 5. Which goes here. Again, lots of numbers. Multiply 2 times 2 times 2 times 2 times 5 in the calculator. You better get 8.
8.
Now let's do 30, which we are already seeing actually. It was 2 times 3 times 5. I have a y and 2 x's. So what do they have in common?
A 2 and a 4.
A 2 and a 5
And 2 x's.
and 2 x's. So therefore my GCF is
10.
10
X squared.
x squared.
Can
Again,
you make these?
taking the smallest variable. Why didn't we have a y?
Because of 80 x cubed.
Yes, it's not a common variable, is it? If you have 3, you're looking for 3 of the same number, right? So for this one, we'll do the prime tree. So does 2 go into 105?
No.
No.
What about 3? How many times?
Too many.
Too many.
Too many for my brain process.
Well, let's see.
Oh, wait.
Anybody look it up real quick? Oh.
Okay.
3 goes into 105. How many times?
35.
35 times? 35 is what? 5 times 7?
And then
I have a negative 30.
2.
2, that's 15.
And 3.
It's 3 and
5.
5. And I have a 75. 3 goes into 75. 25 times, it's quarters. Which is 5 times 5. Now with the numbers, what do they share in common? Do they share a 3 in common?
Yes.
What about a 2?
No.
Do they have a 5 in common?
Yes.
What about a 7?
No.
So with the number, what is my GCF?
15.
15. What is my variable? Do I have a y? Do they have y's in
It
common?
would be
No.
Do they have an x in common?
Yes.
It'd just be x. What if this was a square? Would it still be x?
Yes.
What if this was a square? Would it still be x?
No.
Yes.
Yeah.
Yes.
It's the smallest. I mean, it
What if this was a 5? What would be my GCF?
X squared.
It would be an x squared. Yeah, you're going to take the smallest.